I'm Joe Onorato. This is Romain Guy. We're both framework engineers on the Android team. We're going to talk about supporting multiple devices.
But not quite.
But not quite. Well, if the code's going to run on more than one device, we've got some, we're going to do it on the emulator. And the reason I sort of didn't want to talk too much about multiple devices is all the devices we have now are pretty much the same. There's...
well, I also didn't really know the subject, so...
Oh, that too. So it's, there's the G1. I'll probably call it the Dream at some point.
That's okay, you can call it the Dream.
We're used to that. Then there's the Ion or the Magic or whatever we're calling that. And they're almost identical in terms of hardware. The one is a keyboard, obviously, but other than that, the screen size is the same. That's far and away the hardest thing that you guys have to deal with.
The same physical screen size, same resolution, and same density. Same
part
screen.
Number for the screen, yeah. So, okay. I'm supposed to say that if you want to provide feedback, or please provide feedback on this presentation at havasec.com/io.
And I was supposed to say that for my previous session, so now you know.
How many of you guys came from Romain's previous? Oh God. Okay. All right. Well, good plugging, I guess. All right. So our motto is write once. No, it's not. But we do want you to not have to write a different version of your app for every single thing.
Except we don't promise that you will have nothing to do to make your app work across devices. Yeah. You can write it once, but you might have more work the first time.
In fact, right now the market, you can actually only upload one copy of your app. So you actually do have to have it working with one binary for the whole world, but I know they're working on that too. So here's some of the things you have to worry about. There's OS versions 1.0, 1.1. It's not on there. Cupcake, Donut. I think we let it loose that it's called Eclair last night, but
not just last night. It's
is
public.
it known? Okay.
Do you guys know what Eclair is?
It's E. It's
I'm not talking about the pastry.
Yeah.
Okay. Good.
They had Eclairs at the party last night too, so I think that gave it away too. So there's Donut, and luckily most people, or all the devices as far as I know of, are getting updated to Cupcake. So we don't have too much of this multiple version thing to worry about yet. But this is the mobile industry. The phones don't last forever. So at some point, people will have old versions.
Well, and let's admit it, we like to change phones every now and then. So.
I have one every 2 months or so that I drop it or break it or something. So.
Yeah, you drop it.
Yeah, drop it. Okay, so the other thing we have is configuration. So there's there's locales, orientations, which operator, that's carrier, a lot of other stuff.
And actually, we have good documentation on that.
We do actually, yeah. That's the other reason I didn't want to talk too much about this, because the docs on this are actually pretty good. I have a slide for that later, so it has the URL. These animations are killer. There we go.
Point.
All right. So there's this configuration object. It's android.content.res.configuration in the docs, and it's got these different parameters here. These are the I'm not going to read them all, but you can see them, whether it's portrait or landscape or this density of the screen. We'll get to density a little bit.
Yeah, so basically what you see here, like the values on the right, like you said, it's for the G1. But that should give you a fairly good idea of the kind of things that might change from one device to the other. So obviously maybe you don't care about whether or not the keyboard is visible when you want to display a button on screen, but then maybe the resolution will matter. So
you might need to make a smaller button.
Yeah, so
bigger button.
It depends on your app. And we're gonna focus primarily on density and screen resolution, because those are the ones we think that will be the most difficult for you guys to handle.
Yeah, so for the stuff like locale, I'll just read the docs. It's in there. I'm going to have a URL for that later. All right, so this is the app that we're going to work with. Looks kind of like the launcher.
Yeah.
It's based on the code that Romain had for his
It's a very useful app.
thing. Well, it has little bug droids on there. All right, so this is running in HVGA. That's 320 by 480.
So that's G1.
This is what G1 is, yeah.
Or the phone that you got yesterday.
And so what if it ran on a QVGA device? That's, absolute layout, okay. You could have written that with absolute layout. I don't even know why we have absolute layout in the platform.
But if you do that, I'm going to hurt you, so don't.
Yeah. The worst part about it, though, is that it's got this. If you see down there at the bottom, you have to list the the position of every single view. So that's tedious, right? I mean, if for this view here, that's what is that? 12 different coordinates you have to come up just for that one thing. This file's sort of annoying to write. All right, so this is what it would look like in QVGA if you used absolute layout, and you can see that we're missing one of them. So that's pretty much what we're going to talk about: is how to write this view and have all of your bug droids show up.
Yeah, how to do it correctly.
How to do it correctly. Yeah. Another thing, if for Donut, one of the for Donut, we're going to be supporting 3 different screen. What's the word? Resolutions. Densities?
Well, we haven't decided yet. Let's say densities.
Densities. Okay. But for all these, the screen is going to be about the same physical size. So we're not going to, if we have a WVGA device that's 40 by 800, it's going to be about this big still. It'll be prettier because it's got more pixels, but it's not going to be this big. So if you use that absolute layout, what you'd see is tiny little ones that might be too small to hit with your finger, and they didn't wrap correctly either.
Yeah, and if you use a QVGA device, then you have the opposite problem where everything is too big. So if you think that buttons are too big already on the G1, wait till you try that on a QVGA device.
You get 2 emails per screen.
Yeah. So screen density is a complex issue, and actually in the framework we built a bunch of things to help you deal with that. You probably already encountered something we call the DIPs that we're going to talk about, but DIPs are a special unit, a special way to define pixels that will scale correctly across all densities, and everything will look the same size, the same physical size across the devices. But let's get going.
All right. Absolutely, that sucks. Okay.
Yeah, and actually you can't really use absolute layout anymore because I deprecated it in Cupcake, and people already hate me for that. The layout will not disappear, so you can keep using it, but it's there to show you that it's probably not what you want.
All right. So Romain talked a bit in his last talk about writing a custom view. He called it custom view layout, or what did you call it? View group?
Custom view and then custom view group.
Okay.
So here it's a custom view group.
This is actually going to be a custom view group.
Or custom layout.
They're all subclasses of view, so what are you going to do? All right. These are the links. These are all on developer.android.com, which is the homepage for all the developer, all the SDK docs and stuff. And you have a pretty much complete copy of that in the SDK itself, too. So if you're on a plane or something, it still works.
Well, and also, if you look, sometimes we do write good documentation. So if you look at the Java doc for the view class, there's actually a huge block of text at the beginning that explains many things about layouts and custom views. But apparently people ignore that kind of stuff, so that's why we don't write docs.
But it is there, yeah. All right, so let's stop for a sec. All right, so we're going to go and write our custom view. 4 things we're going to worry about. The first thing, we've got to figure out how big our view wants to be, how big it's going to tell its parent that it wants to be, although its parent is free to ignore that.
Yeah, often they do.
Often they do. We're going to go do the layout, and the first iteration here, we're actually going to ignore what our children said and just do what we want, which is valid. Then there's units, and lastly, we want to make sure that you guys can use your view, this custom view, from an XML file. It's not hard. It's actually less lines of code than I thought it was.
It's not hard.
It's just 10 lines of code that you have to know what they are.
Yeah, they're confusing. Like even ourselves, like we can't remember what they are, and we always have to look at samples that we wrote.
But luckily now we can watch the YouTube video of it. And,
or the slides.
The slides, yeah. Okay, let's talk about units. Actually, no, let's not talk about units. Let's write the code.
The units are boring.
Okay. All right. So the first thing we're going to do, I've got my little script here, is go into our SDK folder, which is this one on my desktop right here, and create the project, tools, and
so we're going to take you through the different steps of creating a new layout, and we'll start with the basic dumb layout, and we'll iterate on that until we get something that actually works and that can be reused and that works across devices. And at the end, we're going to submit that to the Android open source project, and we're going to commit it in the actual source code base, so you can see how it's done, and also see what kind of stuff you have to do if you ever want to commit code that ends up in the project, like what kind of things you have to support.
All right, so didn't work. Perfect. Dash target doesn't work. You can't see that? Is it too low or is it too small? Okay.
Too low.
How's that? There we go. Okay, we created our file. So we're going to go in there. That's back here. I'll move that up for you. Do you want to talk while I'm typing?
Yeah.
Okay.
So yeah, Jode, I don't know if you've used the Android 1.5 SDK. You probably use the Eclipse plugin because it's easy, it's shiny, like you click buttons and stuff. But Jode just created the project from the command line. So we have this tool called Android. It's a simple executable that will generate the project for you, or the directories, the ent build file, the manifest, and even I think a couple of Java files. So now that we have the project created, we can go ahead and just type like ent install or ent reinstall, and it's going to compile the project, ship it to whatever device you have connected to the computer. And when I say device, it can also be the emulator. Like anything we do, like it's the same for the actual physical phones and emulator.
Yeah, so I just started the emulator here.
Yeah, so we're starting the emulator, and hopefully it's not going to take too long because we have nice machines at Google. Next time, start before the talk.
I know, I meant to. Sorry. And the command here is ant reinstall. I don't know why it's reinstall and just not install, but
it is reinstall because there's a difference between installing an APK and reinstalling it. If you try to install an APK that's already on the phone, it's going to fail. So you have to use a flag called -r if you use the adb install command, and reinstall. Make sure that even if the application is already on the phone, the install will work. And usually when you're in Eclipse and you click the run button, that's actually what Eclipse does. It runs this reinstall command behind the scene.
All right, well, I was going to run the project we just created, but it's taken its time to boot up. So it's the Hello World one that you guys have probably all seen.
Yeah, let's go to the next step.
Yeah, let's just go to the next step. So I'm going to open up my file here. This is the image, our little bug droid guy, and I'm going to copy that res drawable, copy that into my drawable. Into there, and same thing with the XML layout file. Let me open that up. Copy that into the layout. So you guys have seen this probably from the GUI there. Let's open that up now. And for this, just to get started, I always like to start with just some simple layout that's already there. So we picked linear layout. It's got these. Should be up by now. Good. We can run it. So that's ant reinstall. Compiling it, and it worked. Failed.
Device not found. Interesting. Try again.
Perfect. Oh, you know what? Let's do.
Yeah, that always works.
This always happens. I don't know why ADB doesn't work, but it doesn't. So let's kill the server.
But actually, at least you get to learn, how we do things.
This is my life.
Yeah, this is actually how we do things on the Android team, because we don't have the luxury of using the Eclipse plugin. Pardon me?
That's what I'm doing. Oh, there we go. Kill all ADB.
Or ADB kill -server. Your best friend. So yeah, I was saying we don't have the fancy Eclipse plugin, and I'm always jealous of you guys whenever I see a demo of the Eclipse plugin, because it's so easy, and we have to do all that crap in the command line. But it works.
Okay. Should be here now.
Yay.
Let's put it on our desktop.
Yeah.
There it is. They're in a row. All right. That took a while, but... Okay, so the next next thing...
You wanted a grid, not a column.
Yeah, we want a grid. So let me copy that other file over.
Because now you get to see the code.
Yeah, now you get to see the code. That was maybe should have done that beforehand. Sorry, but we wanted to show you the sort of the whole step. Maybe it's a little boring, but All right, here's a view.
Feel our pain, damn it.
Okay. You want to talk about these?
Yeah, so that's, for those of you who were at the previous session, this is like how you create a layout. So you extend the view group class. So for some weird reason, it's probably his fault, we have this class called view group, and the subclasses of view group are called blah layout. That makes no sense at all, but that's how it is. So you extend the view group class when you want to create a layout class.
It is actually my fault, yeah, sorry.
Yeah, I'm pretty sure it is. And you need at least 2 constructors if you want to use the layout from XML, which is what we want because we all love XML. It's so easy and nice. The first constructor is the one you actually use when you want to instantiate a view or view group from code. But we don't care about that. Like, writing code for UI is bad. We want everything in XML because from XML we can support different configurations. And if you don't know what I'm talking about, refer to the documentation, to the links that Joe talked about. So the constructor that you're interested in is the second one. So you have a second parameter called the attribute set, and it's basically just a big bag of values that come from XML. So later, we're going to use those attributes to extract the information we want from the XML file. Right now, we're going to keep using the attributes from the parent class, so we have nothing to do, which is always nice. And that fixed grid layout is pretty dumb. You have to specify the width and the height of each cell, and we're going to force the children to have those dimensions. So here you have 2 methods, cell width and cell height. You specify the dimension in pixel, and you can see that we have this request layout call. So whenever you change the size of the cells, we want the screen to be refreshed, so we call request layout that will trigger a re-layout of the whole screen and of that layout in particular. And if we scroll down, we have the fun part. So on measure, we said before that before you want to do a layout, you have to measure the children because you want to know how big they want to be. It can actually matter. In that case, you can see in the middle we have the loop that goes through all the children and call measure on the children. So we saw that before. And then at the end, we have the usual set measured dimension that tells our parents how big we want to be. And you can see a lot of weird stuff going on with the measure spec and the make measure spec. And do we want to go into details about that right now or later? So basically, let's talk a bit about the measure spec. So in the onMeasure method, what you get are actually not just dimensions. Like the 2 parameters, width measure spec and height measure spec, are not how many pixels your parent wants you to be. They're a hint from your parent telling you what size you should be. And we have to do the same with our children. So let's ignore the parameter right now for now and look at the first 2 lines. So we create 2 new specs. So we use the makeMeasureSpec method, and we use the cell width and the cell height that are defined by the 2 setter methods that we just saw before. And we pass as a second parameter to the makeMeasureSpec method the operation we want to use with these dimensions. There are 3 in Android. No, that's 3. That's 2. 3 operations in Android. We have exactly, at most, and undefined. So here we know the size of the cells. So we want to tell our children that they can be at most 80 pixels, for instance, or at most whatever the user specified. If we wanted to force the children to be exactly 80 pixels, we would say measureSpec.exactly. And if we don't know what we want, it actually happens sometimes. Linear layout loves to do that kind of stuff. We would just say unspecified, and then the size you pass doesn't matter. So here we just create our measure spec, and we say, please be at most, whatever cell width and cell height have. We call measure on the children. The children will look at those units and will set their dimension according to that. And the way you do it is at the end of your onMeasure, you can see that we call resolve size. So resolve size is a method of the view class. You pass it the size that you want to be. So here the grid layout is saying, okay, I have I have n children, so that's the count variable. I know that each child can be at most cell width in pixels, and so that's the size I want to have.
Well, so what we're telling here, though, is we're telling the children that what would they like, or asking them, what would you guys like if these were your constraints. So if you could be at most 80 pixels in this case, what would you do?
Yeah.
And we're giving them a chance to sort of traverse down the hierarchy and figure out what they would do in that case, and then we'll bubble up.
But so at the end, we do what our children do with us. Like we tell our parents, what size we want to be. And resolve size, I know it's...
So this is a simple one, because we're sort of ignoring all the details. But for a linear layout, it actually takes into consideration what its children say, and comes up with a size for itself.
Yeah,
and that's how the wrap content mode is implemented.
Yeah, and so this resolve size thing, we pass the widths that we think we want to be, and we also pass the measure spec that our parent gave us, and that measure spec can be at most exactly whatever. In the resolve size, we simply look at those two values and figure out what we should be. So you can ignore the magic that's inside, basically always use resolve size, pass the measure spec that your parent gave you, and just indicate what you think you would like to be. It will, figure out some magic value that works.
So if they said exactly, you'll get exactly what.
Yeah.
It'll use that one. The layout.
So when you're done with the measurement, and I know the measurement is very confusing. Believe me, the first 2 months I was on Android. My first task was to write layouts, and I was like, oh God, I don't understand. So when you're done with the measurement, we can do the layout. So we need to position all the children on screen, and we need to give them a size. So it can be the size they wanted, or the size that we think is best for them. So here it's a very simple algorithm. We go through all the children, and we simply wrap the children. So we put as many children as we can on a row, and at the end of the row, we go to the next row. Actually, here we put only three children per row. So you just call layout on the child. You give the child the x and y coordinates, and you also give it the size you want the child to be. And here, as you can see, we're passing the cell width that we got from the setter methods at the beginning. So we are totally ignoring the size that the children figured out when we call measure. So that layout will always lay out the children with an exact size, no matter what the child wants.
But keep in mind that might be okay.
If
all of these views are your views, and you know exactly how big the bitmaps are.
So
just go ahead and use it.
Yeah. So like I was saying before, if you want, take shortcuts. Like if that's all you need, then stop right there, and your code will be more efficient because it does less work. So that's actually okay to fix the size of the children and ignore what they told you. But that's not correct. Like we can't ship that on Android, so we need to improve it. And also, that's not going to work really well across different resolutions and different screens.
Yeah.
So let's see the next step.
The other thing we're missing here, actually, I realized during your talk, is we're not skipping the gone ones.
Yeah.
But
that's
we don't have any gone ones, so it's not a problem.
We need bugs,
All right. So the other thing to get this actually running is we have to go into our view here and use the right one, content-example.android.
So if you ever wondered how to use your custom views in the XML, that's how you do it.
You type your class name.
Yeah, but the fully qualified class name, how they say in Java, so you need to prefix with the package name. And to make things easier, when you use the standard views, you don't have to say android.widget.listView, but you can.
All we do is search in those classes, in those packages for this thing, so which makes it a little bit slower, actually, but this thing isn't a linear layout anymore, so we'll take that out. And,
so let's run that?
Get it down here, too.
Oh, yeah, DM.
This is one thing I always forget to do, actually, in the XML.
Hey, the beauty of XML.
Every single time. And one more thing in here, shouldn't be too bad, is we actually have to set the size of the cell. It starts out at 0. So we'll do...
Oh, yeah, you want to set the...
Yeah.
So here, because we can't specify the width and the height of the cells in XML yet, we're doing that from code. So the usual, boilerplate of finding the view by ID, casting it, and then calling some methods on it.
Okay. So we'll run it again.
You did not specify the ID in the XML file.
That is what I did.
Yep.
So the syntax, don't forget android.id too. That's That's another common one. If you just say ID, it doesn't...
Well, at least it's not too painful when you do that in your project, because when you forget the ID and you're working on the source code of Android itself, you have to rebuild the whole tree. Takes some time, and your ID goes all crazy because it has to refresh all the tens of thousands of files we have. So usually we're better at not forgetting that.
Yeah.
Okay.
So here we have it.
But so they're exactly 80 pixels across.
And image view stretches by default.
Yeah. So I don't know if it's really visible on the projector, but you can see that the droids are much bigger than the original picture, and they don't look really good, they're scaled, and we don't want that. So we need to honor the measured dimensions from the children.
So we'll do that. This is a little bit of typing. I'll do that.
Well, as long as you do the typing, that's okay.
That's fine. All right, so this is all in on layout here.
Yeah, so we don't have to change the measure method because we've already done it. And usually, actually, you will probably end up not doing much work in the measure method because all you want to do really is measure the children. The hardest part usually is to figure out whether you want the children to be at most, exactly, and specified all that stuff. And if you're really courageous, you can go look at the source code of linear layout. And if you're still reading it after a couple of minutes, then please apply for a job. I would love to give you linear layout to maintain. So here Joe is modifying the layout method. So we're actually asking the children what are their measured width and measured height. And that's something that you have to keep in mind is when you want to know the width and the height of a view for some reason in your UI, you have two different methods. You have get width and get measured width. And they can actually be different. In many situations, the value will be the same, but they may be different. So the one you want most of the time is get width because it gives you the actual size on screen. Get measured width is really useful only for layouts because they're the ones who care about what the child thinks it's want to be. So here Joe is just updating the call to layout to keep.
And I'm going to have it centered in the view too.
And you're actually centering. So because we said to the children, okay, we want you to be at most 80 pixels large, they might be smaller. So we have a couple lines of code here, int left and int top equals that center the child within the cell if they're smaller than the 80 pixels that we specified.
And we'll make it wrap correctly instead of hard coding it to 4 columns too.
Which is always nice. So let's give that a try.
Let's see if that actually runs.
Just entry install.
Yeah.
The padding?
Again?
Okay, so no, you don't take care of the padding of your children in the layout because the padding is inside the child. So it's part of the measured width.
Well, if the layout itself had padding,
if the layout has padding, you have to deal with it. What you would deal with is the margin of the children, because the margins are outside of the bounds of the children. If you want a good example of that, you can look at frame layout, linear layout, relative layout, I think. They deal with that kind of stuff. And usually, if you don't care about padding and margin, just forget about them. Take the shortcut, because as soon as you start taking the padding and the margin into account,
it doubles the amount of code.
The code becomes much more complicated. So be glad that we do that kind of stuff for you.
So here they are, the right size and centered in their cells.
Okay, and if we were to inspect that layout in hierarchy viewer, we would see that the items are smaller than the cells in which they're contained.
You want to do that?
No, let's go ahead.
Okay. All right, so next we're going to actually make the density, right? So if we ran this in WideVGA, what we would see, I won't do it because it takes so long to start the emulator, but what we would see is all 6 of these androids right in a line.
Yeah. Well, so that's exactly the screenshots that you saw at the beginning. We specified, in this example, we specified the size of the cells in pixels, so there are actually 80 pixels. And if you are on a device that has a higher density, then 80 pixels are much smaller physically for you as the user. And that's what we want to fix. It's not an issue right now, but it's going to become an issue for all of your applications really quickly. We have stuff in the framework that take care of compatibility for older applications, but it's best if you guys do it. So
we were going to do is sort of show you how to hard code it, but I think I want to just skip that.
Do you want to skip that?
Because it takes a little while. So While this is going,
Okay. Well,
I'm going to restart the emulator here while we talk.
I'm pretty sure you will have the slides available somewhere, so we can. It's not much code. It's like a few lines of code.
4 lines of code, but
and if you want to know more about supporting the density and how to compute the right size, then just send us emails. We'll point you to the examples, and we'll probably talk about it really soon on the blog, on the forums.
So I think what we'll do is show you how to use resources then instead.
Yeah. The attributes, you mean?
Yeah, attributes.
So let's see. So let's see how to get the attributes from XML.
And so I said it was about 10 lines of code. It's really about that. So there's this is you have to add a file called resvalues_adders.xml.
Yeah, actually, it doesn't have to be called adders.xml. It's a convention, and I would love that we change this convention because I can never pronounce adders.xml. You should try with a French accent. You'll see.
You don't want me to do my French accent?
No, you don't.
So there's go ahead.
Yeah. Well, yeah. So Joe here is just creating a new resources, new series of resources, and something that's called a stylable is basically a set of resources that can be modified by the theme. So if you ever created a theme and you changed, like the full screen mode, the window background, the appearance of your text views or stuff like that. That's because they are declared as stylables in the framework. And then in a stylable, you define all the attributes that you want to be able to use in XML. So it's just a name and a format. So here, dimension. So dimension is a fancy name for all the units we support. So that means that when you have a dimension attribute, you can say 1 px for pixel, 1 dip for device-independent pixel. You can say 1 mm for millimeter. You can use 1 inch. We have a bunch of different units. And we support a bunch of formats, so you can have floats, you can have enums, you can have flags, integers, booleans, strings, references.
Enums are kind of fun, actually. They let you. They do exactly what enums would do. They give you a name in the XML file, but it becomes an integer.
Well,
it becomes any integer in the data structure. So
if you ever used a linear layout, for instance, and you specify the orientation, you say orientation equals vertical or horizontal. That's an enum. Defined as an attribute. So here we just define the 2 attributes we need to specify the width and the height of our cells. And let's see how to use that from code.
Well, we'll add it to the XML too.
The XML. And you need to recompile.
So this is the magic part that I
always forget about.
Always forget.
So yeah, you've probably seen that namespace in the root tag of all your XML layout files, and you probably wonder like, why do I have to have that thing that it's pretty weird to look at.
So there's actually 2 parts to it. This is just the prefix that tells us that this is going to be an Android
attribute,
yeah. And then there's your package name, and then Android is the one that it's sort of regularly in.
Yeah, and you want to change the namespace name.
Oh yeah. Cool.
And so when you create your own attributes from XML, because the name of your attributes could potentially get in conflict with the attributes that we define, you have to specify a namespace for your application, just like you have to use the Android namespace. So just this weird prefix, then the package name of your app, and then when you specify the attribute, instead of using Android colon whatever, you use the name of the namespace you just used. And here, Joe just declared the width of the cells to be 80 device-independent pixels, which will scale automatically with the density of the device. That's some framework magic. And the height is just 100.
Yeah.
So it's, like we said, it's actually pretty easy to create your own XML attributes. The only thing is that you have to remember this syntax. And I don't know how you can humanly remember this syntax. So it's nice to have examples. Yeah. And actually in the SDK, you have a bunch of examples that use that. So if you look at the home sample, for instance, we use custom attributes heavily. Have you recompiled the...
I haven't yet, because we need to put the Java code into.
Okay.
So I'm just going to copy and paste it.
So now there's some more weird syntax.
So what this... so we're going to add this big hunk of code to the constructor here. And what all that XML did, there's your r.java file. And that generated, inside that, it generated a static final array of resource IDs that can then be used to this obtain styled attributes function, and it'll get you this thing called the typed array, which is magic. And
so the typed array is basically all the attributes and all their values that you've defined in XML.
But just for this one just for this one thing.
Stylable.
For this one stylable, yeah. And we're going to get the width and the height out of that. The thing we skipped was the pixel size thing. Just briefly, there's this typed array thing has 4 or so different versions of get pixel or get dimension, and the one we have here is used for widths. So if the rounding would cause your pixel to go down to 0, it actually forces it to be 1, just so your widget doesn't completely disappear. It's not so much useful for the width of your actual widget, but if you're going to do something like draw a border, you probably still want to have a border, even if it's a really small border.
Yeah, it's the second worst API name ever.
Yes. What's the...
Set compound drawable within interesting bounds. That's the first one. Again, so you saw that it's pretty easy to get the attributes from XML, but we have to admit that the API like typed array, get stylable, it's not very intuitive. So we wanted to show you guys, the code that you have to type, so that at least you can remember what it looks like, and so that you can know what to look at in the source code of the examples when you want to do the same in your applications.
So here, while we were doing all that, we restarted the emulator here, and it's running at wide VGA, which is 480 by 800. Yeah. And you can see that Android isn't really ready for it yet either. The home screen sort of ends. But, and the icons are small. So here's our little button.
Well, and the Androids are small too.
What?
The Androids are small too.
Yeah, the Androids are small too. Well, they shouldn't be, actually.
You have to modify the DPI property of the system.
I should have done that.
Yeah.
Crap.
That's okay.
All right. Well, if this were to run on a real device, which don't exist, which is why this talk is all theoretical anyway, then this would have looked right. There's a way to get the emulator to build it. I'm not going to show it because it took me about 20 minutes to figure it out.
Yeah, so one of these days I'll write an article on the blog to show you how you can start the emulator with the appropriate density, and you will see that things actually work correctly so that you can at least test your application. It's not that hard. It's another one of those things where you have to find a weird configuration file somewhere in the system and change one of the properties. So we'll document that.
And if somebody were actually making a device that was that size, they would have done that, obviously.
Yes, unless they want to ship a weird device.
Yeah.
So we're done with the code?
So I think we're done with the code, yeah.
So let's go to the fun part.
The fun part, yeah.
Okay. So now we'll show you how, this code is awesome, obviously, because we just wrote it. Joe's a great developer. And we're going to now submit that for review to the Android open source project. So Joe will show you the comments that you have to do on your side to submit a patch. And then I will show you how, on our side, we look at your patches and how we approve them. And the cool thing about it is everything that we're going to do right now, it's exactly what we do every day, several times a day internally. So we use the exact same tools, we have the exact same process. The only difference between you and us is that you don't have the right to submit something in the tree whenever you want, and we do. And you'll see, it will be obvious. We have a cool button that you will never see on your screen. We got to have some perks, working on the Android team.
So we're going to check this into the samples directory in the tree. And we're actually really going to check it in right now. So if we break everything, then the build is broken.
I think the build is broken already, so that's okay.
I think the public one isn't. All right, so we copied it in there, and now we're going to go into development samples. This whole thing is completely command line in our world. Yeah, we're going to show you Git.
I won't say anything bad about Git today.
Git is great. Actually, you know what? Linus had a nice talk at Google where he slammed everybody but Git. So Linus is a jerk, and Git is annoying.
So can I say that Git is a pain in the butt?
Yeah. Cool.
So Git is a pain in the butt. No, it is actually awesome. Let's just say that to me, as a user that likes Macs, they forgot about the user part, so it's not very user-friendly. It's a bit of a pain. And we're currently transitioning internally. We used to be on Perforce, and we're switching to Git so that we use the same tools that you do, so that we can also feel your pain. And believe me, we do feel it.
So I just deleted, what I had just done is deleted all the files that we don't actually want to check in. Our samples directory doesn't have all the build.xml files because they have hard-coded paths and everything.
Okay, let's end the review.
Yeah.
So we have this tool called repo It's basically a smart wrapper on Git because the Android project is, we like to make things complicated. So instead of having one repository, we have currently 152 or something like that. And obviously, handling 152 Git repositories by hand would be, quite tedious, to remain polite. So we created this tool called repo that takes care of most of the work for you. So when you type repo sync, it goes through the hundreds of repositories and syncs them. So when you do a repo start, let's back up a little.
That's way back up here.
Yeah, stop typing stuff. So when you do repo start, you're just starting a new branch, so here called sample. So when you want to commit something to the Android project, you have to start a new branch. Don't ask me why.
This is all documented somewhere.
Yeah, so. It's because of the way Git works. Anyway, so you have to start a branch. And if you don't, I can't help you. I still don't understand.
It's about 10 commands, and you have to rebase something somewhere.
Yeah, so just create the branch. Never forget about creating the branch.
So we're going to add the file to Git.
Yeah, so now that we...
Or add the directory, rather.
Yeah, so...
Status shows us all our new files.
Let's back up a little.
Oh, we didn't do that?
Yeah. Well, did you show before you did the add?
Yeah, we did the commit. It's just that's all we had to do.
Okay, anyway. Yeah. So for those of you who know Git, we just stage the files in the index. For those who don't, just, I don't know, go read a book about Git and you'll understand. Anyway, so the point is, in Git, there are several stages where your files live. So you modify the files, then you have to do a Git add to put them in something called the index. So you do repo start, my branch, then you modify your files, you do Git add, you put them in the index, and when you're ready, you do a Git commit. The fun part about a Git commit is that it commits the files on your machine. So they're still on your machine for some reason. Okay. So here Joe is just adding the commit message, and you can see in the comments at the bottom everything that we did. So we just added a bunch of files. That's all the files in the project. And when we're ready, we can finish the commit. So now files are committed locally, and we need to upload them to the Android project. So for that, we use the command called repo upload. And repo upload is really smart and figures out that you have commits in your current branch. It packs them.
You and says, would you like to upload those?
Yes. So yes. And then, go ahead.
It's interesting.
Failed. The remote. Oh, do you have the SSH key?
Yeah.
Huh. Try again. When in doubt.
Huh. All right. Well.
You don't have the key.
I don't have the key.
Well, let's do that right now. Go to the website and put the key in everything.
Right, here's my public key if you guys all want to see it.
I'm pretty sure they can't. But they will have the video. You'll change your key.
I'm not going to open my private key, just the public one. I hope that's the public one.
Yep. You'll have to do that yourself. So when you want to deal with repo, and I'm sure there's a good reason, but I was never told the reason, you need to put your public SSH key in your account. So let's do that.
So yeah, you have to go to the settings tab.
So that's
SSH
review.
keys.
Review.source.android.com.
Oh, yeah, or r.android.com also works too.
R.android.com.
Paste that in there. Click add.
That's it.
Let's go back and try that again.
So all of that, like the SSH keys that explain. If you go to source.android.com, they explain everything.
There we go. Okay, it worked.
Okay, it worked. So now the code review is online.
The code review is online, yeah.
And
if anybody here wants to go comment on it, you can heckle me.
Actually, you can. I mean,
you really can. It's live.
We welcome comments. You can look at changes from other people and say that you disagree with them, that you agree with them. So if we see like 20 people from the outside said yes to a change, then maybe it's a good idea to accept the change. So now it's my turn. Joe's work is done.
Actually, I need to add you as a reviewer.
Oh yeah. Well,
so this
you don't read. Okay, you can.
Yeah, let me do it. Because this is what you guys would do. You can see it's I've uploaded it. The owner is me, and I'm going to put in here.
And if you don't know who should be reviewing your change, just don't put anything. We do receive emails. We know that new changes are coming in, and from time to time we go look at them and we add ourselves as reviewers. Yeah. Anyway, so
but I'll add him. It'll send him an email.
So add reviewer. Here you go.
All right, go ahead.
And our reviewer. So I switch to my machine. I'm already logged in on Gerrit, so the exact same tool. And if I go to my changes, reviewable. Yeah, it doesn't like Safari sometimes. Anyway.
Oh, this whole thing, by the way, is written using Google Web Toolkit, too. Just by a guy, Sean Pierce, is on our team. He's fantastic.
Okay, so where is your change? Here we go. So that's just change, and you can see that all those other changes are changes that people made to the framework that I could review, but it's not necessarily my job to review those changes, but they still appear for me as changes I can review. So let's go look at Joe's change. And it looks exactly the same as Joe's UI. And actually, someone commented on the change and gave it a +1.
Good for you.
Thanks, whoever you are, Frank. But actually, no, that's nice, because you can see that, so his comment says, looks good to me, but someone else must approve. It's a can comment. So that means he thinks that it's a good thing to have in the platform, but he doesn't have the approval rights. So somebody like Joe or I have to go ahead and give the approval. So here now, I can look at all the files. I have the diffs, looks good. But actually, I see here that Joe forgot to put the make file, because we use make in the open source project. So it probably tells me that Joe never built that code in our platform. I promise we never do that. So let's say, I will say no score, because I do appreciate the patch. I want the patch to end up in the framework. So I say no score, and I will leave a comment. Here I could say that I would prefer that you didn't submit this. That means I disagree with you, but you could convince me otherwise. Do not submit. You're really wrong, and I don't want to hear about it anymore.
And actually, the do not submit actually force. The system won't allow it to be submitted.
Yeah,
Somebody's reviewed it that way.
It's gone. We have total control over your stuff. Okay. So, geez, you didn't even compile your stuff. I had the make file. So I published my comments. You can see here that my comment was added. The score is still 0. Let's go back to Joe's machine.
So I've got my make file already.
Yeah, especially because, well, maybe you know how to write a make file, but
yeah.
I have no idea.
If you guys use the build system, that's my fault. If home screen is his fault, the build system is my fault. So here's what the app make files look like. This is sample code. Here's the name of the app. This one here says it's being built against the SDK as opposed to the private APIs.
Which is a good thing. Okay, so now we've done that, we need to modify the patch that Joe uploaded, and that's where many people make the mistake, and I do the same quite often actually, because of the way Git works. If you do a new commit to commit the change that you just did, then repo will treat the old commit and the new one as two different changes, which is not what we want. So
we're going to amend this. We're just going to do git.
So we add the file to the staging area, and then we do a commit with the magic flag called --amend, and that modifies the previous commit with those new changes. So we still have only one commit with all of our changes. And there's still one mistake we can make after that, and that we often do.
We'll see if we make it, because I don't know what he's talking about.
I'm sure you do. Repo upload replace.
Oh, yeah. Okay.
Yeah. So if you do a repo upload right now, it will create another change, and that will piss us off, because we have two changes that are pretty much the same, and we have to go ahead and
figure out what the other one is.
Yeah, figure out what the other one is. Take care of rejecting one of them. So what you have to do is repo upload --replace. That means that you want to modify the current change that you have on the repo.
And you say which project you want, which is the one we're in right now.
So here you can indicate you can see that the number between brackets is the number of the change in the Gary tool on the web. It's pre-populated for you. Just make sure that it's the right number.
Yeah, it usually is.
It usually is.
It guesses, though. It's heuristic, so it's not 100%.
Okay.
Now it's re-uploaded it.
Now it's re-uploaded. My turn. And if I refresh the page, if Garrett refreshes, wow, we have a bunch of people who would like to comment on bugs.
You can see it reset go back up to the grid there. You can see it reset
the score, yeah.
All the statuses.
Yeah, because we changed the code, we can't trust what people said the last time. And here you can see that we have the patch set number 2, so we can look at the patch set number 1, and we can look at the difference between the two. So now the patch set number 2 has the make file, so I'm happy with it. I won't go through the whole code. And so when I'm happy with it, I publish comments, and I say, looks good to me, approved.
Yeah, we're going to have to verify it, too.
Yes, but let's approve first. So now it's approved. It just means we can submit it. That doesn't mean that the code will compile or that it's not going to do bad things to the build. So at this stage, what we're doing internally is we want to try the patch locally. So here we have those two commands we can use, either repo download or the git pull. And all I would have to do normally is copy that, paste it in my shell. Like for instance here, I'm in my source tree. I just paste the command. I execute it. This will bring the change that Joe made into my source tree. I can compile it. I can run it. I can see if it works. I can see if the build is still going. And when it does, I go back to publish command and I say verified. So I verified that the change is correct.
This is actually the big bottleneck for us. It's not looking at the code. It's actually downloading it all and building it.
And now that the change is both approved and verified, I have a new fancy button here that you will never see on your machine, unless we start, trusting you guys to become contributors, approved contributors. So this is a new submit button. So the cool thing here is that once we are on the website, I don't have to grab the code, do the patches locally on my machine to patch our tree, and then do another commit, or Joe doesn't have anything to do. I just press this button, and that's it. The code is in the tree. We can see here, change has been successfully merged, and Joe's code is now available on source.android.com. There's one last thing that you want to do on your machine, the abandon.
The abandon, oh yes. So remember we started a branch, and if I continue working on that branch, oh God, I don't even know what happens. It just doesn't work.
Yeah,
so
just
you
don't do
have
that.
So what happens is that I work for about 2 weeks and then realize that I'm on a branch and try to submit, and
you're screwed.
Then I'm completely screwed, yeah. So this repo abandon, the project was called sample, and it's in this project, so dot. And it did it, I guess.
Yeah, and now can you go to the GitWeb to see your code?
Yeah.
So now everything is fine on Joe's machine. We accepted the change. When you abandon your change, the change really disappears from your machine. So you want to do a repo sync to bring back the change that you just sent and removed from your machine. It's a bit weird at first, but that's how it works. So if we go to development samples. Yeah, development. So that's the web interface to Git. And you want to look at the master tree?
This is master, I think.
Okay.
Yeah. Tree.
Samples.
Samples. And
are you sure you're in master?
I don't know. Well, anyway, it's probably there.
Let's prove it's there.
Do you know how to find it?
Go back. Scroll down. Were you in master? No, whatever.
So this is another thing. I worked for about 3 weeks, and I was submitting to master, and I thought I was working on Donut. So that was a little bit hard, too.
There we go, master.
Oh, look at that.
It doesn't even know how to use the tool he wrote. Well, somewhere.
Well, there's some code somewhere.
It's maybe in Donut. It's maybe
I wonder if I put it in Donut.
Maybe it's in the...
Huh. Well, I have some homework to do after this and find out what build I broke.
Well, like we said, we are in the transition to the new tools. But at least, that gives you an idea of what the workflow is. And again, this is exactly what we do internally. The only difference is that we don't use the public website. We have another instance of this Gary thing, and we have another Git tree internally. But the tools are the same. The workflow is the same.
The scratching of our heads is the same.
Yeah.
It's,
the only difference is that, Joe could just upload his patch and say, hey, I trust myself, and submit it.
Yeah. And then I break some branch. Okay.
Yeah. Like I did today.
So we're just about out of time, but if you guys have any questions,
well, there's nobody.
Certainly entertain. Come up to the mic. Since this is
yeah,
being recorded.
Go to the mic for the questions.
Come on.
Okay, so it's a Git trip, so use git fetch.
No,
Stash.
Oh, you mean you saw how I was doing that there? Yeah.
Okay.
When you've submitted your first patch and you're waiting to get approved or not, is there a way that you can do additional work, or are you kind of frozen in case you have to amend
that's
it
actually-
later?
That's actually
the nice thing about
what
Git.
you don't have to do in that case is do repo abandon. You can continue working on top of your changes.
But
The
you
only
can-
thing is it gets a little bit hairy if
Or you can
you have
switch
to
to
make
another
changes.
branch.
Or you could switch, if it's totally unrelated, you can switch to another
Okay.
branch too.
I just want to make sure you get in a state where you can amend without adding.
Yeah, you can. What you end up having to do, and I've done this, is you have, instead of doing amend, you make changes and you rebase them into a different order and squash them and everything
Okay.
if it works. All right, thank you.
I have no idea what the code is.